we balanced our angles here. Now, for all the stuff that we're doing from here on out, we're going to use balanced angles. Don't use the original data because it's not correct anymore. So if you're looking at here, we're not using the 45, it's going to be 50. It's going to be 35. And it's going to be 35. Okay? So we're going to use the new balanced angles in this next calculation.
You're doing that to force it so you can get a whole 180.
Exactly.
Okay.
I'm using it to force it to close. Now, steps 3 and 4 says I have to balance my angles. And I'm going to be going back and forth. Sorry, Anna.
No problem.
Anna's recording for me, so the people that are watching this at home, she's going to have to follow me. All right, so we got to compute the azimuths. So steps 3 and 4 is compute azimuths. Okay, so the first azimuth I have a known azimuth from northeast to the actual azimuth that's out in the field. And it's 185 degrees, 20 minutes, 30 seconds. So I'm going to start with the northeast AZ. And it is 185 degrees, 20 minutes, 30 seconds. All right? Now, the way this works, there is a pattern. You have an azimuth, you get a back azimuth, you add an angle. You get an azimuth. You add a back azimuth or subtract to get the back azimuth, you add an angle. Azimuth, back azimuth, add an angle. Azimuth, back azimuth, add an angle. Azimuth, back azimuth, add an angle. They say if you say it 3 times, people will remember it. So I got an azimuth, what do I have to do? Back azimuth. So if my azimuth is the first azimuth that I have is for a known line. So the first true azimuth that I have to give of my traverse is going to be using this neither angle here of the 1821. So my first azimuth that I have to calculate is I'm going to add that angle northeast AZ to of the 18 degrees 21, 25. All right? So what that means is I'm finding, I know this black line here is 185 and I add the 18. It's going to give me this azimuth here, 0 being straight up north. So when I add that, I'm going to get an azimuth from the northeast to 2, and that's going to be 203 degrees, 41 minutes, and 55 seconds. All right? When you look back at this, doesn't that look, we already know it's past 180, but it's not up to 270 yet, so that looks pretty good. Okay, always check. The second thing when I'm writing this, always notice how I'm writing. I'm saying I'm going from the northeast, and I'm starting at the northeast, and I'm going to point 2. So that tells me the azimuth from northeast to point 2 is 203. And this is where we get an azimuth, get a back azimuth, add an angle. So if my azimuth is greater than 180 degrees,
You subtract 360?
I subtract 180. Because the way that it works, I'll draw a sketch over here. So if this is out here at 203 degrees, right? The back azimuth says, now I'm sitting here and I'm looking backwards. So if this line is projected, what is this angle here? So that's why I'm subtracting the 180. So I know this is 203, and all I care about, because it's opposite interior angles, is that angle here. So I am going to subtract 180 degrees from that to get the back azimuth, AZ of 2 to the northeast. So that would give me 23 degrees, 41 minutes, and 55 seconds. So that's that little angle in here. So that would be the back azimuth if this is the northeast and this is point 2. All right? Now, we have an azimuth, we get the back azimuth, we add an angle. Now this is the important part. What angle do I need to add? I'm actually going to add, so I was sitting here, I got an azimuth. Now I'm sitting down here, I get my back azimuth, and I'm going to turn an angle. So I need to add the angle at 2. So the angle at 2 says, let me get my purple pen so I can be color coded. The angle at 2 is 32, 40, 50. Okay? That is going to give me the azimuth from 2.2 to 3. Okay? So that's going to be 56, 22, 45. So azimuth, back azimuth, add an angle, get an azimuth. Now, the azimuth from here to here, and I'll write these over here. So this is 203, 41, 55. The azimuth from 2 to 3 is 56, 22, 45. Okay? Now, azimuth, back azimuth, add an angle. Get an azimuth. So what do I have to do now? Back azimuth, right? So if the azimuth is less than 180, we add 180. So now I'm going to add 180, so I'll do the back azimuths in green. So I'm going to add 180 degrees, and that's going to give me the azimuth from 3 to 2. And that's going to be 236, 22, 45. Okay? Now, so the azimuth, and I have to write it up here, 3 to 2, the 236, 22, 45 is my back azimuth. Azimuth, back azimuth, and I'm going to add the angle at 3. The angle at 3 we said was 100, 1, thank you, 35, and that is going to give me the azimuth from 3 to the northeast. So when I add that, I get 336 degrees, 24, 20. All right? Now, if this happened to be more than 360, what would happen?
Subtract.
We'd have to subtract the 360 because we don't do anything in survey that's greater than 360 degrees. It's still mathematically the same angle. It's just more of a rotation. But we're not going to worry about that. So, azimuth, back azimuth, add an angle, get an azimuth. So what that's saying is from 3 to the northeast, from here to here, is 336, my writing's bad, 336 degrees, 24, 20. Okay? Now, here's the nice part. Survey always gives us a check usually, checks and balances. Azimuth, back azimuth, get an add an angle, get an azimuth. Now, I have my azimuth, and I'm going to get a back azimuth. So it's 360. Do I add or subtract?
Subtract.
I'm going to subtract 180 to get the back azimuth, the AZ of northeast to 3. So that's going to give me 156, 24, 20. So I'm going to add that closing angle, and it's called the closing angle because it closes your traverse. So the angle that I'm closing on is going to be the 47, 17, 35. So when I add these up, what should it be? It should be this first angle because I'm taking that back azimuth and adding that 47 degrees, and it should be the 203, 41, 55. If you do this and your math does not give you that beginning azimuth, because it's telling me the azimuth from the northeast to 2. If it's not the same as that, double check your calculations, okay? So it will give me 203 degrees, 41 minutes, and 55 seconds. So it does check, okay? I've done them before where I made some type of mistake on my balanced angles. The first time I ever did this, I didn't use balanced angles. I used my original, and it never, I was like, why is this not working? It's because I didn't force it to be 180 degrees. I didn't force it to close, all right? So that is step 3 and 4. So I've computed my azimuths for all those lines. Now, if you take a look at your instructions on step 5, it says, determine the northing and easting of the beginning point. Okay, this one's super simple because you're going to download this from the data sheet. Somebody has to give it to you. You have to have a known start point. Our known start point was given to us at the very beginning on our field data sheet. So here is the northing and easting of our initial start point. So the next part says, step 6 says, fill out the traverse computation form in the direct method, because it's the direct method because we took these data directly out in the field. If it was pure math, then it would be an indirect calculation. So we're actually using physical data to solve for this. All right? So I'm going to pause here, and then we're going to go to the other blackboard, and we're going to start the table of data.